Good afternoon, my YouTube viewers. In this particular video, what we're going to do is we're going to do a practice question with a hypothesis test with estimation. So the practice question is, a company claims that their employees work an average of 40 hours per week. A random sample of 30 employees shows a mean work week of 38 hours with a standard deviation of 5 hours. At a 95% confidence level. 1. Test whether the company's claim is valid using a hypothesis test. And 2. Construct a 95% confidence interval for the population mean and interpret the results. Well, number 1, you don't need to perform a hypothesis test on this if the 38 hours is going to be less than 40 hours. But for the sake of this exercise, we're going to go ahead and do the hypothesis test on it. So your population mean is 40, and your sample mean is 38. So you know already that your sample mean is less than 40. So your sample size is 30. Sample standard deviation is 5. Confidence level is 95%, and the degree of freedom is 29 because that's the sample size minus 1 is your degree of freedom. So now we calculate your test statistic is, your null hypothesis is, test statistic is greater than critical value t, means the mean equals 40, and the alternate hypothesis, which can be either H1 or HA, is the test statistic is less than the critical value, which means mean does not equal 40. So our test statistic is B8 minus B7, so that's sample mean minus population mean, so that's -2, divided by B10, which is your sample standard deviation, divided by the square root of B9, which is the square root of the sample size. So your test statistic is -2.19. And your critical value is t. We're going to be using the t distribution, .inv dot 2t, that means it's a two-tailed test, equals 1 minus B11, so that's 1 minus 0.95, comma B12 is your degree of freedom of 29. So your critical value is 2.045. So basically, if we're going to interpret the results, so if B17, that's your test statistic, is greater than B18, that's your critical value, then we're going to fail to reject the null hypothesis. Otherwise, you're going to reject the null hypothesis. So your test statistic is 0.219, and your critical value is 2.04. So B17 is less than B18, so you're going to reject the null hypothesis. So we're also going to calculate the margin of error. Margin of error is B18, that's your critical value, times B10, that's sample standard deviation, divided by the square root of B9, which is 30. So your margin of error is 1.867031, and then your lower bound is B8 minus E7, so that's 38 minus 1.8, so that's 36.13. Your sample mean is 38, and your upper bound is your mean plus 1.86, so it's 39.86, and your population mean is B14. So you can see here we've got our lower bound confidence interval being 36, and then your sample mean is 38, and your upper bound confidence interval is 40, and your margin of error is 1.86. and your population mean as 40. So you can see that the sample mean is less than the population mean. So the sample mean does not equal the population mean. So that means you're going to reject the null hypothesis in favor of the alternate hypothesis, whereas the test statistic is less than the critical t-value. So you can see your test statistic is negative 2.9089 and your critical t-value is 2.4. But let's just change this here, 39, see what happens. So with the 39, you're still going to reject your null hypothesis. So let's make it 40. So your test statistic is 0 and your critical t-value is 0.24, and if B7 is less than, if B17 is less than B18, reject the null hypothesis. Well, you can't reject the null hypothesis. So let's try this, 41. And that says reject the null hypothesis either as well. So let's try this, 38. And then come over here. Let's try this. So now it says if the absolute value, so now what I've done is I've changed this to say if the absolute value of B17, that's 2.19, is less than B18, then that's going to be failed to reject the null hypothesis. So the absolute value 2.19 is greater than B18, then you're going to fail to reject the null hypothesis. So let's check this. So that's not working. So that doesn't work. I just thought, well, maybe it might work if you make it an absolute value. But the absolute value doesn't work either. So if B17 is greater than B18, so you've got 40 and 40. Then if B17 is greater than B18, then you fail to reject the null hypothesis, but we've got 0. So I'm just wondering here. So it says fail to reject the null hypothesis because, so we've got test statistic is absolute value of B8 minus B7. So what I'm going to do here is I'm going to come over here. says the test statistic does not necessarily have to be an absolute value. The absolute value is used when comparing the test statistic to a critical value or calculating the p-value. The test statistic can be positive or negative, and the absolute value is applied when the test statistic is less than 0, which is the case in one-sided alternative hypothesis test. The t-distribution is symmetric about 0, so the absolute value is used to ensure the test statistic is compared to a symmetric distribution. So it said that the test statistic can be positive or negative, and the absolute value is applied when the test statistic is less than 0. So that's why I made it an absolute value. So we're going to fail to reject the null hypothesis. Let's try 35. It says fail to reject the null hypothesis. Let's check 30. So it's just generally not working. So it says if it's 40, then you reject the null hypothesis. If it's 41, you reject the null hypothesis. And then let's try 42. So if it's 42, you fail to reject the null hypothesis. Let's check 43. 43, you fail to reject the null hypothesis. At 40, you fail to reject the null hypothesis. Let me try this. It says reject the null hypothesis. So really what we should say, test statistic is greater than the critical value, which means the mean is, so the mean isn't 40 really, is it? So the mean isn't 40. So if the test statistic is greater than the critical value, then it's the null hypothesis. And if the test statistic is less than the critical value, then it's the alternate hypothesis. So what that does is that just lets you know that, the problems that you can have formulating a null hypothesis. So we've got here 38. So if the test statistic is greater than the critical value, then you fail to reject the null hypothesis. So that concludes this particular video, and you can see how problematic it is. So we found out that you use the absolute value of the test statistic when it is negative. So I found that out. So that concludes this video. The next video is going to be on another statistical subject, and I hope that you decide to watch it.